All right, welcome to the Explainer. So, OpenAI's GPT-5, it's finally here, at least for some early testers. We're diving into what they've found, and honestly, it is not what anyone expected.
Get this, the very first impressions are a total paradox. Testers are saying it's the closest we've ever been to AGI, real human-like intelligence. And yet, it's actually worse at writing than the previous version. How does that even work?
So yeah, that's the big puzzle we're tackling today. How can something be a massive leap toward superintelligence, but get worse at what seems like a simple task? To figure this out, we've got to throw out our old ideas of what intelligence even is.
And believe it or not, the answer starts, well, it doesn't start with silicon. It starts with stone.
When you really think about it, what made us human? It wasn't just bigger brains. The real game changer, the thing that set us apart, was our ability to use tools. We started extending our minds, our hands, and that changed everything. Here's a perfect example. Chimps have way better short-term memory than we do. So what did we do? We basically outsourced our memory. We invented writing. And by losing that internal skill, we freed up our brains for much bigger, more complex ideas. It was a trade-off, and it was a brilliant one.
Okay, so what does this have to do with AI? Well, it turns out this exact same idea, this trade-off, is the key to understanding why GPT-5 is such a huge and kind of weird leap forward.
See, here's the absolute heart of it. Older models, you could tell them, use this calculator, and they would. But GPT-5, it's not just using tools, it's thinking with them. It walks into a problem like a master craftsman entering their workshop. It looks around, it picks up tools, it makes a plan, and it starts building.
And that's why it craves a certain kind of tool. It doesn't want simple things. It wants power tools. Stuff like internal retrieval to search through a whole code base, web search for doing its own research, a code interpreter to test things, and most importantly, actions. The ability to actually do stuff, to make changes. It wants to figure things out for itself.
Okay, that's all the theory. But what does this tool-based thinking actually look like when you put it to work? This is where it gets really, really cool. So the testers gave it a truly nasty task, a horrible dependency conflict in a huge code base. If you're a developer, you know this is an absolute nightmare. It's the kind of problem that can eat up days, and it's something other top AIs just couldn't solve.
And just look at how it tackled it. This isn't just guessing. It was systematic. It ran a command to investigate the problem, it took notes on what it found, it figured out the exact conflict, and then boom, it edited the right files in the right places and solved it. First try, one shot.
And the other models? They basically just threw their hands up. They'd spit out a few suggestions like, here are some things you could try, and then leave the hard work to the human. They were like a glorified help file. GPT-5 was an actual engineer on the job.
The gap gets even wider here. They asked the models to build a website from a single prompt. Look at the results. One model just gave a plan, no code. Claude Opus gave a decent prototype, but no database. And GPT-5? It built a full, production-ready app with a database, ready to go. So, okay, the testers decided to really push it. They gave it a new challenge, something more creative. Build a website that looks and feels like the old Mac OS 9.
But here's the crazy part. They added a major constraint. No frameworks, no libraries, nothing. Just pure old-school HTML, CSS, and JavaScript. It had to build absolutely everything from scratch.
And, you guessed it, GPT-5 nailed the entire thing in one shot. And we're not talking about just a pretty picture of an old desktop. This thing was alive. It was a fully interactive system.
I mean, look at what it built. A working paint application, complete with a color picker and different pen sizes. You could actually drag the icons around on the desktop. And then, and this is the part that gets me, it decided all on its own to save the icon positions. So if you reloaded the page, your icons would still be where you left them. It wasn't just following orders, it was anticipating what a user would want.
So a tool this powerful, this different, it means we have to change too. You can't just talk to it the same old way. This is a totally new way of working with AI.
And that brings us to the biggest takeaway. You have to stop thinking of it as prompting a model. That's the old way. You have to start thinking of it like you're prompting an agent.
You're not writing a command. You're giving a mission brief to a new team member.
So how do you do that? You don't just throw a wall of text at it. You give it a compass. You point it in the right direction. You say, here's what the project is about. Here are the important files to start with. This is how things are organized. You even define key terms and, critically, tell it what a successful outcome looks like. You're basically its project lead.
So let's step back for a second. What does all this actually mean? For the future of AI, sure, but what does it mean for us?
What we have here is what the testers are calling a spiky model. It's a specialist. It's not as good at writing. In fact, it can produce some pretty generic kind of LLM slop text. But it traded that skill for something else. It is, hands down, the best coder in the world. And that trade-off resulted in this: a 7% leap in our ability to automate software engineering. Now, 7% might not sound like a huge number on its own, but put it in perspective. That jump from about 65% to 72% of the way there is apparently the single biggest leap forward in AI coding since GPT 3.5 first hit the scene. It's a massive deal.
So here we are. It really is like a new stone age for AI. The conversation is no longer just about what an AI can say. It's about what an AI can do. We've been given these new, powerful stone tools. The only question left is, what are we going to build with them?